Bismillahirrahmanirrahim and Assalamu alaikum. Welcome to the another lecture of Programming Fundamental. In this lecture, we're gonna cover the very important and interesting topic type conversion. So, what is mean by this heading? When you mix apple with the orange, for example, if you are going to uh, make a shake of apples and the orange, then when you uh, drink this shake, whether the taste of apple dominate or orange. So this is all about the type conversion. But in the C++, we do not have apples and we do not have oranges also. So why this is written here when you mix apples with orange? It is because of the data types of the variables. It basically means that what happens when you mathematically involve the two variables of the two different data types. For example, if you divide an integer value by the float, so whether the answer will be in an integer or answer will be a float value. If you multiply a character with an integer value, so what output data type will you get? So this is what this heading basically means. Type conversion. When the operator operands are of the different data type, that's what I have just explained, that during the mathematical operation, if the operand, let's suppose a plus b, so a and b are the operand and the data type of a and b are both different. If it is so C++ will automatically convert them to the same data type because both operand must be of the same data type. So C++ does this automatically. It will bring them both the operand on the same platform, and this can affect the result of the mathematical expression. You are, let's suppose, expecting a integer value, but because of the type conversion a float value occurs, or you are expecting a float value, but because of the type conversion does by the C++, automatically you will get the different value. So you must be aware of how the C++ does this type conversion when the operators are of different data types. Let's suppose if an integer is multiplied by the float, what data type will the result be? Meaning that the result of this multiplication will be of data type of what? Whether integer or float. So just like in a military, we have different ranks of officers. So data types in the C++ are also have ranks. One data type outranks the other. So for example, if at the moment we don't know about the ranks, but the data the data type that has a superior rank and will also dominate the result as well. As the result will be in the data type that has the more rank, higher rank. So here are the rank hierarchy. Just like in military we have different ranks, so here are the data types which are arranged in the order of rank. The very lowest rank is of integer, though we have character as well as before the integer, but I have written very few data types just to clear the concept. For the complete table you can go to the chapter 3. So integer has the lowest rank, and then we have float, it's like captain, then major, and then lieutenant colonel or whatever. So integer has a very lowest rank if it is involved with the variable whose data type is float, so answer will be in a float. If a float is multiplied by a variable, that is double, answer will be in a double. This is how the ranks works. If the two operands are involved in a multiplication or any mathematical operation, the data type of the output depends upon the data type of the operand that has a highest rank. Now there are two things the C++ does. One is that the C++ automatically does this type conversion without letting you know, and it does two things. One is promotion and one is demotion. Promotion means, let's suppose integer is going to multiply by a float variable. You will get answer in a float, but first the C++ will promote this integer value because it have to bring both operand on the same platform, on the same data type. But there is also a case where a demotion can occur. Convert a higher data type to the lower data type. Now this is what we have to learn and understand the action of the C++ in order to avoid any wrong or uh, unfamiliar data or result. Two things, one is promotion and other is demotion. When operating on the different values of the data type, the lower one is normally promoted to the type of the higher one, and that we call a promotion. For example, this operation, years variable is going to multiply it by the interest rate, and we assume that years is in integer and interest rate is float. So when C++ encounter this statement, it will first in the background promote this year variable to the float so that both can multiply each other, and answer would also be in the float. Before multiplication takes place, year will be promoted to the float and we get the answer in the floating point. In this sort of case, in this sort of examples, normally when we are multiplying the two variables, normally we get the promotion. We never get demotion in this case. There is only a single case of demotion when we are using the assignment operator. Here is an example. We have integer type of x and y has a value of 4, and then we have a float data type z that is value of 2.7. We are going to multiply by y and z, that is 4 multiplied by 2.7. If this assignment operator and this x is not there and you will print this multiplication using the cout, you will definitely get 10.8. But have a look on this complete expression. The answer of this multiplication is going to assigned using this assignment operator to x, and x is integer value, it cannot hold 10.8. The moment you assigned a floating point value to the integer value, it will discard the fractional part, it can only save 10. So here the 10.8 is basically a floating value, that is the value of the higher rank. It is demoted to the lower rank. A float value is demoted to the integer value, and this is the only case of demotion in the C++ when we use the assignment operator. And on the left side of the assignment operator, the variable is of lower data type. To handle this situation, we can change the data type of x and we will keep it float, then we will get 10.8. Alright, so this is type conversion that is automatically done by the C++, and we should aware about the C++ action in order to avoid any wrong information. Let's suppose in this example, let's suppose this is the same example I put in the exam and ask you what will be the output, predict the output, and you write okay it's 10.8, but no, it should not be the cannot be the 10.8 because of this typecasting. Now there is also a manual way of doing the same thing. You can also promote or demote the variables manually. What we have just covered is something that C++ automatically does, but there is also a manual way of doing the same using a very simple command, static casting. This is only typecasting. That is, typecasting means type conversion means that something that happens automatically, but when you does this deliberately or manually, it is called static casting. Now there are different ways of doing this static casting. Manually changing the uh, data type of the variable. The very first command is static underscore cast and then the data type and the value. Here is an example of using this command. We have this variable character ch. Ch is equals to single quotation c and then semicolon, and this statement cout is going to print this value. Now what is going to happen here? I write static underscore cast and then this angle bracket is integer, which means that I want to promote this character data type to the integer. I want to static cast to the integer whom this ch is the value, name of the variable. Now I'm going to the code block to explain you further about this. Alright, so this is a program. I have declared a variable character of data type character name ch and stored c or whatever a. Now this line is going to print the character as it is. This line basically doing the typecasting, static casting, changing the data type of a variable manually. The very first command to do the static casting is to write static underscore cast and then in angle bracket you need to write the data type to which you are going to promote or demote, and then in round bracket you need to write the variable type or the variable name. So firstly we will it will be display 65, oh sorry, character a, and then the numeric value will be the ASCII code of this variable, like this. Here is another program. In this program I have declared this floating variable. This is an example of demotion. Basically it's self static demotion. This is a float variable a of value 123.12. In this second line or I displayed this variable a, and then I demote this using the static casting like static underscore cast integer and then a. Then here is the output 123.2, the original number, and then when we static cast we restrict this to the whole value. Another way to do the same thing, this command is very difficult to remember. So what you can write to do the same is just to write the data type to which you want to promote or demote, round bracket, and the variable name. This is also the same thing. Instead of writing static underscore cast and then angle bracket, data type, value, you can simply write the data type to which you want to go and the value you want to promote or demote. Now see the same output. Again, see the same. A and then 65. So this is typecasting. We will back to this program. First let me show you this. So there are various ways to do the same thing, and what I just tell you is this thing. You just remember this command integer or whatever the data type you want to go, and then the value or the variable name. Another way is this round bracket, data type where you want to go, where you want to promote, close the bracket, and then type the variable name or value. Third command is this. So you have three commands. Whatever you like, you can do to perform the typecasting, static typecasting. I prefer to use this one. This is simply to understand and remember. Now this program is basically practice you to use the static casting. It basically uh, this program is basically use the typecasting to avoid any integer division. This has a variable name integer books, integer month. This program is basically going to calculate how many books you can read in a month. For example, if I read 47 books in 2 months, and if I divide 47 by 2, so since both uh, variables are integer, so I will receive a whole number. So to avoid this, uh, I can do the typecasting statically. So per month is basically a double variable. So it first read the books and then it reads the month. Now why I need static casting here? Why I should not put this month as a double? Because first of all understand why we are using static casting, because if these two are integer value, they can possibly bring a floating point value. All right. So but uh, but because they both are integer, we will have the integer value as a result, but uh, they may bring the floating value as well. As we have to keep sure in this. Now in order to get the floating value, we one option is that we can make either the numerator or the denominator a floating value. That is, I can change the data type to this float or double, and I should not worry about the floating values. But the number of books I have to read cannot be in a floating value, can never be a floating value. So to keep the integrity, I have to limit the data type of the books integer. Same is the case with the month. Whenever someone asks you that how many month you will going to take to read this book, you will say 2 months, 3 months. You will never say like two and a 0.25 months. So you will give a whole value for a month and the book. But there may be a case when uh, books are divided by month, there can be also a floating value. But the since both operands are integer, it will produce the integer value. So no matter you are using the double variable here, it will never give a floating answer unless you do the typecasting before the division. So this program is basically using static underscore cast command to convert the data type of the books to the double before dividing with the months. So one operand between the two will is now double. So the answer is also comes in the double category, and then it is easily assigned to the per month. To understand the program, I have written this simple program. Two variables of type integer, and as I told you that let's suppose this A is basically the number of books and this B is basically the number of months, and they both can never be a floating value. I will never say that I will read two and a half book in a 3 and 0.75 months. So they both naturally exist in a whole value. Now I have answer, but there may be a case when I divide, let's suppose 12 by 5, a floating value can occur. The operand are naturally exist in the whole value, but the result can arrive in a floating value. So I write two variables, answer and answer 1, as a floating variable. Now this is simple pure integer division. A divided by B. Since both are integer, so the answer is also an integer value and it is assigned to the answer, and it is printed here, and it says effect of no typecasting. That is, in this line or in this line we are not doing any typecasting, static typecasting. So we are expecting integer value here instead of the real float value. But what happened with the answer 1? We first change the data type of A to the float and then let it be divided by the variable B. So we will get the floating value here, and then the floating value assigned to the answer 1, and then it is printed. Here we go. Effect of no typecasting, answer is getting, we are getting 2, and then effect of typecasting, we are getting the original or complete answer. So this is the effect of the typecasting, because and here we are doing the static typecasting, that is typecasting manually, because when we are not doing typecasting manually, we are getting the wrong or incomplete answer. So I hope now you understand this program. This is also the same program that I just execute earlier, but now in this example they are basically turning the integer value to the character. They declare a number as an integer value variable and assign a value 65, and then when they are going to print, they print the character value. They basically demote this. You can also do this by simple is typecasting command that I told you, this one. All right, so I believe that you have understand this typecasting. both automatically as well as the manual way of doing the same. Now the another concept is overflow and underflow. Underflow or overflow is a condition usually occur when we assign a value to the variable that is either very large, that is overflow, or very small, that is underflow, to be held into the variable. Now, how you quantify a value as very large or very small? Because it depends upon the size of the variable. We know that every variable occupy certain bytes in the memory and have certain range. So if you put a value that exceed that range, then it comes in the category of overflow. Or if you put a value that is very small, that precede the range, then this will comes in the category of underflow. Once this happens, the variable value will be wrapped around a set of possible values. Let's suppose the let's suppose this is just for the illustration purpose. Let's suppose the range of integer is from 1 to 10. What is mean by wrapping? Let's suppose the range is from 1 to 10. Now if you assigned a value 11, this 11 is very large as compared to the range, so it will overflow, and once it is overflow, it will be wrapped to the lowest value and it will display 1. Likewise, if you saved value 0 to the variable whose range is from 1 to 10, then this 0 is too small and underflow condition exists. And once underflow condition exists, value will be wrapped and the very maximum value 10 will be shown. This is one possibility. Different system may display different warnings, error message, stop the program, or continue execution using the incorrect value. There can be different cases. This is a simple program explaining the overflow and underflow condition. We have declared the short test variable. Short is a data type, test variable is a name, and the value of this variable is 32767. Why? Because the range of the short variable is from in my computer is it is from minus 32768 to positive 32767, and initially I have saved this value in the variable. Print the value, I got the same value. Now here what I am doing, test variable is equals to test variable plus 1, that is the present value of the test variable will be incremented by the 1. Now when 1 is added, it will be 32768, but 32768 positive is not in the range of the variable short, so it will be wrapped to the lowest value. And see what we are getting, its contents are wrapped around to the data type lowest possible value. We are getting minus 32768. Now this variable test var has this value at the moment, and now what we have done, test var minus 1, minus 32768 minus 1 means even lower value. So this is the underflow condition. Minus, it will be minus 32769. This is even underflow condition. So this time it will be wrapped to the maximum value 32767. This is the, so this concept is known as the underflow overflow condition, and we must avoid this in order to get the garbage value. So this is you have to do yourself. So hopefully you learned up till now. You understand the concept of typecasting and static typecasting. Okay, Allah Hafiz.